Previously, we talked about there are two methods for the curtailment of reinforcement bar in the continuous slab. One is obtained from British Standard at 110, which you can get it from figure 3.25 of the British Standard as illustrated here. The other one I obtained from references written by Mosley. This is the references. Refer to figure 8.2. This is the simplified rules given by Mosley. While doing curtailments of the reinforcement bar in continuous slab, you may choose either one of them, but don't mix them up. There are slight differences in terms of the amount of reinforcement bar provided at the supports. Of course, there are conditions for the applications of these simplified rules. For the Mosley method, the requirements are the loading should be substantially uniformly distributed load, and the span of the slab should be more or less equal. As for the British Standard, there is one more conditions, where the loads should be maximum or applied across all the continuous slab. Now bear in mind that Eurocode itself does not provide the simplified rules for the curtailments of the reinforcement. Instead, Eurocode 2 approaches from the fundamental approach. You may refer to figure 9.2 in Eurocode 2. This diagram explains to you how do you do the curtailment. We had one video previously explaining the concept behind the diagram. Now coming back to today's method, we did one example previously on the curtailments of reinforcement using the simplified rules given by the British Standard. Today we're going to try another example, totally different scenario, but we're going to use the methods given by the Mosley. Although the amount of reinforcement bar at the support differs, the principles behind doing the curtailments are similar. By knowing how you use the simplified rules given by Mosley, you may adopt the same principles to work out the curtailments of reinforcement bar using the British Standard. The final outcome would be more or less similar, except for the top reinforcement at the end support, under most circumstances. Without further ado, let us look into the example. This time we deal with a thin slab. The thickness is only 100 mm and the span is relatively long. We are dealing with the secondary bars. Due to the small effective depth and long effective length, the slab will be quite heavily reinforced. Now you are asked to do the curtailment for the slab. Among the considerations for curtailments of reinforcement, this include the maximum bar spacing. The secondary bar should not be less than 20% of the main bar. However, in this case, we only deal with secondary bar. No information is given on the main bar, but based on the amount of reinforcement bar provided here, which is quite large, it is very likely there won't be any issue on the secondary bar less than 20% of the main reinforcement. Next is about the minimum bar area, then minimum bar curtailment, and then lastly, the dimensions are to be rounded up to the nearest 25 mm. Given the span, the thickness, and the type of the reinforcement, as well as the amount of reinforcement bar provided, the minimum bar area shouldn't be an issue, but if you are not sure, you can do a simple check using this formula here. Since we are dealing with the slab, it is typically designed on the basis of 1 meter unit width. Therefore, the B here it will be taken as 1000 mm. Next, you need to determine the effective depth. The effective depth is determined from the thickness minus the cover, which in this case is 30 mm, minus the main bar size, although it is not given here. We assume that the bar size of the main reinforcement and the secondary reinforcement are the same, following the typical practices in the construction industry. Now you take the thickness minus the cover 30 minus the main bar size, which is 10 mm, and minus half of the secondary bar size. This is for you to get the effective depth to the bottom reinforcement. As for the top reinforcement at the interior support here, you will do the same. Thickness minus the cover minus the main bar and minus half of the secondary bar size. That will give you the effective depth of 55 mm. You need FCTM, which is governed by the concrete strength. In this case, your concrete strength is 30. Less than 50, you can use this formula. Substitute the value. Your FCTM is 2.9. FYK, it will be 500, as we choose to use H bar. Substitute all the value, we have our AS minimum of 83. But what is provided is 700 something. That means it is sufficient. In terms of the spacing, you also have no issue. This is due to the thickness less than 200 mm, and we deal with the secondary rebar. This formula will be applied. 3.5 times the thickness, that means 350, and a maximum of 450 mm. That means your maximum spacing, it will be 350 mm. In this case, you're providing 100 mm, which is less than the maximum. With that, you have no issue with the maximum spacing as well. That means the proposed reinforcements of H10 100 and H10 100 here are satisfactory. Now you are good to go with the process to do the curtailment. You may refer to the diagram here. You need to provide the amount of reinforcement bar, not less than what is specified. And the locations of the curtailments should abide to the dimensions given. You see one more item here that will govern the locations where you do the curtailment. This refers to the anchorage length. This anchorage length is governed by where the reinforcement bar should be located. By referring to figure 8.2 in Eurocode 2, for this length, with the thickness less than 250, you know that the bond conditions is good. That means the anchorage length here, it will be relatively short as compared to those located at the poor bond conditions. Theoretically, you have to do the calculations to determine the effective anchorage length. Now, as a simple rule of thumb here, under good bond conditions, it will be somewhere 36 times the bar diameter, and under poor bond conditions, it will be 52 times the bar diameter. Let's say we adopt these two values here. So in this case, your thickness of the slab is only 100 mm. It is less than 250 mm thickness. That means the entire slab, it will be under the good bond condition. Therefore, you may use the effective length of 36 times the bar diameter. 36 times the bar diameter, it will be equals to 10 times 36, which is 360 mm. That means if this length and this length, as well as this length, is less than 360, you will use 360. Otherwise, you will abide to the length given here. Having this set, let us first deal with the curtailments of the bottom reinforcement. Given H10 100 at the midspan, you want to reduce it by half. By reducing to the half here, you can double the spacing. That means you do the curtailment on the reinforcement bar alternately, something like this. The spacing between the reinforcement bar and the midspan is 100. Then you do curtailment every alternate bar here. It will make you the spacing here to become 200, near to the sub. By doing so, you might need to check the maximum spacing. The maximum spacing that you have calculated, it will be 350. That means if you curtail every alternate rebar here, it will become 200, still not more than the maximum of 350. Also, you need to check for the minimum bar area. The minimum bar area that we have calculated, it will be 83. Now you reduce the amount of reinforcement bar to 50%, it is 393, still more than 83. With that, you can proceed with the curtailments of the reinforcement bar, leaving you #10 200 with the amount of reinforcement bar of 393 mm square near to the support, which is here and here. Next, you need to determine where are the locations where you're going to do the curtailment. Given your effective span 6.75 meter, 10% of it, it will be 675 mm. That means this distance is 675 mm. As for this, we are talking about 20%. That means the distance, it will be 1350 from the interior support. This is from the end support and this is from the interior support. Now that we have done with the bottom reinforcement, let us deal with the top reinforcement at the end support. We are talking about 25% as compared to the main reinforcement at the midspan. The amount of reinforcement provided at the midspan here is 785. 25%, it will be somewhere 196 mm square as compared to the AS minimum, which is only 83. That means your AS minimum is acceptable. You may provide the reinforcement bar here at the spacing of 200 to make it consistent with this one. This will pass the maximum spacing as well as the AS minimum. Now, if you would like to save up more reinforcement, you can even go up to 350 spacing, which is the maximum spacing allowable. And your AS provided here is still more than the 1/4, which is 196 mm square. This is up to you. As the spacing and the arrangement of the reinforcement bar here is not influenced by the others. Maybe you could try to use #10 350, or if you wish to keep it consistent, for example, in this case, we will just use #10 200 for easy supervisions at the construction site. And then you can end your reinforcement bar here, which is 20% of the effective span. 20% of 6750 mm is equals to 1350 mm. Next, we will deal with the top reinforcement bar here. The amount of reinforcement bar provided, #10 100, which is this one. You want to reduce it by half here, you may follow the methods that we do here. Doing curtailments of the reinforcement at every alternate reinforcement bar that give you double the spacing. And we have done the checking already. The maximum spacing is not exceeded and the minimum bar areas is also fulfilled. That will give you #10 200 mm. Next, you need to determine the locations. You will keep with #10 100 up to a distance of 15% of its effective span. 15% is equivalent to 1025 mm. This 1025 mm is to be compared with the anchorage length. The anchorage length is 360. That means it is more than enough. Now, if you observe, 0.15 times the effective length is actually equals to 1012.5 mm. Remember that we need to round up to the nearest 25 mm for easy conversions at the construction site from the SI unit to imperial unit. Now you have two options here, either to round it up or round it down. If you round it up, it will become 1025. And if you round it down, it will become 1000. Now you're going to ask yourself, which one it will be more critical? Your best options it will be for you to round it up, as you're talking about measuring the distance from here, from the surface of the interior support. The bigger the value, that means you provide more reinforcement bar here. If you round it down, that means there will be a little stretch here does not fulfill that 100% reinforcement. Therefore, your final outcome it will be 1025. That's why you get this 1025 mm here. Therefore, you will stick with 1025 mm. And then your 50% bar here can end at 0.3 times the effective length, which is equivalent to 2.025 meter. Again, this is more than the anchorage length required. Therefore, you will stick with the 2025 mm. This represents the final detailings after you have done the curtailment. The midspan and also the interior support you have #10 100, and then you're allowed to reduce to 50% of the reinforcement bar here. That means you can curtail the alternate reinforcement bar, leaving you the spacing of 200 mm. The Mosley methods allow you to have the ring bar here to be around 25% of the tension reinforcement bar here. Although we provide #10 200, that we would like to make it consistent. If you wish to save more reinforcement, you can actually increase the spacing up to 350. Since the reinforcement arrangement here is not really governed by any other adjacent reinforcement. That means you can put the reinforcement at any spacing.